Hi, and welcome to my video on electric power. Now, in this video, my main emphasis is to give you a cheat sheet and explain it that will help you in the upcoming videos and working the problems. I'm gonna talk a little bit about power in general, but the main purpose is to get you where that you can do series circuits, parallel circuits, and then series parallel circuits. And in series parallel circuits, that's where you're going to get your real exercise at. So let's have at it. First off, I'm going to review Ohm's law, where that the voltage equals the current times the resistance, and the current in the circuit equals the voltage over the resistance, and the resistance and so when you got a circuit here, the element, you can calculate the other values from with these identities. Pretty straightforward. So let's talk about power. Power is in watts. That equates to watts. And we all seen that. 100-watt light bulb is way brighter than a 20-watt light bulb. A 750-watt heater is not as hot as a 1500-watt heater. So it's pretty straightforward. So let's talk about it. Power equals the voltage times the current. So literally, the voltage times the current for a 100-watt light bulb is some amount of current times 120 volts equals 100. And I'm going to do a little problem with that at the end of this. And another way you can look at it is power equals the current squared times the resistance. And this is really handy when you're describing the loss in power lines, extension cords, stuff like that. Because the voltage that's going through that extension cord doesn't matter when you calculate the power being lost. It's the current going through it squared times the resistance of that wire. That's how you calculate it. I mean, you can measure the voltage at either end, but how can you do that if you, efficiently? And then the power equals the voltage squared over resistance. So when you got a circuit, and you try to calculate the power, you can take what you got there, whether you got voltage and resistance, voltage and current and resistance, and solve it from with the missing one from the two that are present. Now, if you try to find the voltage, current, or resistance in a circuit when power is known, you got the voltage in the circuit equals the power over the current. Now this is a handy one right here. You really need to make sure that is on your cheat sheet. All this will be in your cheat sheet. This is one that you're going to use solving circuits a lot. And less likely is going to be the voltage equals the square root of power times resistance. But that's handy to have. This will be time when you have the power being dissipated and the value of resistance, the current. And here's another one that you're going to use is the power over the voltage. And you can also calculate the current from the square root of power over the resistance. Handy dandy to have. And then your you can calculate the resistance. That is power over current squared. And also you can go get your resistance from the voltage squared over the power. And that's that. You know, you should stop at this point. Pause your computer and write these things down. Power equals voltage times current. Power equals current squared times resistance. Power equals voltage squared over resistance. Your voltage is the power over the current. Also, you can calculate it from the square root of power times resistance. Your current is, you can calculate that from power over the voltage. Also, you can go the square root of power over resistance. Resistance is calculated from power over current squared. Or the resistance can be calculated from the voltage squared over power. Very straightforward. So I'm going to erase this lower part, you know, since you was probably stopped and wrote this in your cheat sheet. And we live and die by the cheat sheet. It's kind of like taking off an airplane, you know, you live and die by your checklist. So let's talk about the 100-watt light bulb. So what we know the power equals 100 watts. The voltage equals 120 volts. So what is the current? What is the resistance equal to? You know, so let's go at the current first. And if you look at your cheat sheet, and you can see the current is the power over the voltage. So the I equals the power over the voltage, and that equals what? 100 watts over 120 volts. And you know, if you're doing things by hand, you can take and cancel out the zeros. That's valid. You can only do that on the right hand zero, and I'm not talking after the decimal point neither. And you go back, but so divided by 2, that'd be 5 over 6, which equals 1 and no, what was I saying? 4. Okay, enough of that. It equals 0.83 amp. All right, now for the resistance. The resistance equals the voltage squared now you can say V squared over R. That is valid, but I'm using E squared just so you get used to associating E with the voltage, because you're going to go through text and stuff like that, and if that isn't on the tip of your tongue, you get messed up. So voltage squared over resistance, and that equals 120 volts squared. Over 100 watts. Wait, let's see. V squared over power. My bad. Which is 100 watts. So now we go and you chuck it in your calculator, you come up with 144 ohms. Now, I want to point something out about this. If you take your ohm meter and you put it on a light bulb, a 100-watt light bulb, you're not going to read 144 ohms. You're probably going to read a couple of ohms, if that. And that's because the filament in the light bulb, when it heats up, the resistance goes way up. So when the bulb is operating, it's 144 ohms. When it's cold, it's really low, only a couple ohms. So I'm going to leave it at that. And My next video is going to be series circuits. I said at the end of Ohm's Law I'm going to series circuits, but no, we are going to series circuits next. So I'm looking forward to seeing you in the next video. Thank you.